Hello everyone, my name is Cynthia and today we'll be discussing the p-values. P-values represent the probability of obtaining a result at least as extreme as the current one, assuming that the null hypothesis is true. This is also a measurement that tells us how much our observed data disagrees with the null hypothesis, and whether the relationship that you observe in the sample also exists in the larger population. The null hypothesis states that there is no relationship between the dependent and independent variables, and that the coefficients of independent variables denoting the dependent variable will be 0. We assume that the null hypothesis is true until have enough evidence to reject it. The alternative hypothesis is that there is a relationship between x variables and the y variables, or the outcomes. It cannot be proven to be true. We can only fail to reject the alternative hypothesis or reject the null hypothesis. As part of null hypothesis significance testing, we try to discredit the idea of the null being correct by assuming it is true, and then showing that if we make that assumption, something contradictory happens. So how do we interpret the p-value? If a p-value is low, then we will reject it. This means that it's statistically significant and that there is more evidence that have against the null. Now, if it is a high p-value, then we will fail to reject the null. So the selected level of significance at which we will be comparing the p-value to will be A, or otherwise known as the probability of incorrectly rejecting the null. Usually a 5% is acceptable. This means that a 5% of probability of rejecting the null is acceptable. Other percentages can be used, but for our purposes, we will be using the cutoff of 0.05. This means that we want our sample value to be at least in the top 5% of most extreme values in our distribution before we consider the value against that hypothesis. So if a p-value is less than 0.05, then we'll go ahead and reject the null. If it's greater than 0.05, we fail to reject the null. So 3 factors that can impact the p-value will be the sample size. So the larger the sample size, the more likely we'll find a significant relationship if one exists. Another important measure will be the spread of the data. So the more spread of observations, the lower the p-value. So one way that you can correct the spread of the data is by looking at the C-score and making sure that you have a low standard deviation between your variables. So multicollinearity refers to when 2 variables are highly correlated and they convey the same information. This is difficult to estimate the relationship between each independent variable and the dependent because the independent variables will tend to change in unison. So one way that we can look at the variance is by looking at the variance inflation factors. So this indicates the change that in one variables are associated with the shifts in another variable. So this range will go from 0 to 10, and you want it to be as low as possible. So what we have here is we see that weight, BSA, and pulse are highly correlated with one of the other variables in the model. So what we can do is look at the correlation scheme between each variable and the other variables in the model, and we see that weight, BSA, and pulse once again have really high correlations. So if we're looking at pulse, we should go ahead and remove that factor from the model since it is part of it is already represented in other variables that are included. If we're looking at weight and BSA, they recommend that we take away BSA because it would be more difficult to calculate. So we'll keep weight, age, the DIR, and the stress, and then we run the regression again, and we see that the VIF is lower. We also see that the R-squared compared to the previous one has lowered, but that is okay. We're looking at what model best fits our regression model, and this way we will not have multicollinearity where different variables are giving the same information. An example that's provided by said statistics on YouTube. If you would like more information on that one, I'll link it down below. But essentially we're looking at, does a country's latitude affect their Winter Olympic medal tally? And then some of the X variables that they used were the average latitudes, average elevation, and log population. So once you run the regression model, you see that the coefficients on the side and the interpretation. For example, the first coefficient would be that for every additional degree of latitude, the expected number of metals increases by 0.523 on average, holding all other variables constant. But what we're looking at today will be the p-values for each independent variable. So each independent variable tests that the null hypothesis that the variable has no correlation with a dependent variable. If a variable is lower than 0.05, like the p-value, we say that it is statistically significant and worthwhile addition to our regression model. If it is higher than this, it is not statistically significant and can reduce the model's precision. If it is a low p-value, then it is a meaningful addition because it changes the predictor's value and are related to the changes in the variable. So once we look at this, we can see that the ones that have a low p-value, so the sen-lat, the log population, and the cons, those are all ones that we would like to keep. Now, if we look at the elevation, the p-value is rather high. The p-value is saying that the null hypothesis is correct. So it's saying that the coefficient would be close to 0. And in fact, when we look at the coefficient, it is close to 0. So this would be something that we would want to take away from our model in order to make it better. So once we do so, we have a higher p-value of the overall model, and we're able to better predict the effect that the independent variables have on the dependent variable. If you would like to see more about this specific model, it'll be linked down below. Like I said, it's going to be the understanding the regression outputs. And then if you want to look at more in depth about the multicollinearity and multiple regressions, that middle linked will give you more information on that. Thank you for your time. Have a great day.